Welcome to the National Tree Seed Center here in the Atlantic Forestry Center in Fredericton, New Brunswick. I'm Kieran Volk, I'm a lab technician here, and I'm going to bring you on a tour of the lab where we do all our seed processing to show you what type of equipment we use here in 2021. So come along. This is the main room of our lab. This is where seed begins and ends its journey. This is where we assess the seed quality when it comes in, because we have seed that comes in at various stages, whether it be full cones or seed that still needs to be cleaned. We use our microscopes and equipment here to assess that purity, as well as we have our reference library and computers that we can do research on how best to process the seeds. Also behind me are the entrances to our freezers where we store the seeds long term, as well as our dirty room and dry lab, which we're going to check out next. Here we go. This is our drying room, probably one of the most important rooms that we have in the lab. This is because when seeds come in from the field, they have a fairly high moisture content, and we have to bring that down to maintain viability. We do that by putting it on drying racks, and these are our drying racks for larger seed lots. They're built using a window screen so that air can flow through the bottom and through the top. Usually seeds will come in a paper bag, and this helps dry it down during the whole process from picking to shipping to receiving in the lab. But this doesn't ensure that the seeds dry. So what we'll do is we'll empty the bag into the drying rack and try to keep it at a level of 1 to 2 fruits deep so that we can get a very level dry through the whole process. We also have a smaller seed drying rack in the back here for smaller seed lots and for drying things throughout the process of cleaning it. An important aspect of our dry room is that we keep it at a relative humidity of 25 to 30%. This is because we want to dry down the seeds when they come into the lab to this level. The way that we can check to see if the seeds are at this level is by using a water activity meter. These sensors measure seed respiration in real time. This is so that we can establish a benchmark ERH, a benchmark water activity level of 0.25 to 0.3. This is a standard benchmark level that seeds will maintain viability in long-term storage. We keep all our supplies in an orderly fashion. This makes it much easier when it comes to a busy part of the year when we have lots of seed lots coming in and lots of seed lots going out. One of the things that we store in these cupboards is mason jars. These glass mason jars are very important for storage because if they're sealed tightly and they're sealed properly, there should be zero moisture leaving or coming into the seed lots. This is very important to keep the seed lots at the same moisture content throughout storage. We use mason jars on our research collection because we're opening it and closing it, and we need easy access to get into the seeds. But for collections such as our conservation collections where we don't need easy access to it, we use a trifolate aluminum bag. And this also will have zero moisture coming in and zero moisture coming out. Containers should match the side of the seed lot going into storage. Empty space in the container must be minimized to reduce moisture. In mason jars larger than 125 milliliters, if there's empty space, we include a packet of silica gel to absorb residual moisture. If the seed lot is so small that there is significant space left in a 125 milliliter jar, then we put the seeds in plastic vials within a larger mason jar. The diameters of mason jar openings should not exceed 6.5 centimeters because larger openings do not prevent moisture exchange. Another thing we keep in our cupboards are germination trays. We use our germination trays with the cellulose Kimpac as our germination media so that we can assess viability when the seeds first come into the lab, and we do germination tests every 10 years to assess the viability of our seeds in long-term storage. The majority of our germination tests are conducted with 4 repetitions of 50 to ensure uniformity of the sampling procedure. Other seed labs often conduct their tests using 4 reps of 100, but we work with smaller seed lots, so reducing seed waste is crucial. The greater number of seeds in a rep, the higher the statistical confidence in the true mean of the total seed lot. And now we're going to head to our initial processing room. This is our cone tumbler. We use it to extract seeds from different conifer species. It has a mesh drum that spins around and tumbles the cones so that the seeds can fall out of them. After the cones tumble for about 20 minutes, we can take the seeds out from the drawer underneath. This allows easy access. This drawer even comes out to make it very easy to take the seeds and bring it to other parts of the lab. In larger seed labs or seed extraction facilities, they'll have versions of this, but on a much bigger scale. This small version can tumble about 6 liters of cones at a time. Once you get more than that, then it doesn't work as well. But it's not limited to only using conifer species. We also use it for alder, as well as poplar and willow that have a lot of fluff in it. When working with poplar and willow, we add this smaller mesh around the drum so that the fluff can stay in the middle and the seeds can drop to the bottom. This is our brush machine. We use it to take the wings off of seeds to reduce volume for storage. We specifically use it on maple and ash and some other species such as New Jersey tea. Now, it's a very abrasive machine, so you only want to use it on species that can take a very rough rubbing. It works by having 2 brushes inside a drum that spin in a circular motion. You can adjust the distance between the brushes and the outside of the drum so that you can have it more abrasive or less abrasive. The downside of this machine is it's really only good for working with larger seed lots because it requires cleaning after every different seed lots to avoid cross-contamination. If you don't want to use a brush machine, or you want to work on a more delicate species, you can use a cloth bag. Now, the cloth bag is probably the best tool that you can use for cleaning seeds and the one that we use the most often here in our seed lab. It's very easy to use. You fill it up about 1/3 full and you close it and you simply rub it. And you can rub it for various amounts of time. You can rub it harder or softer so that you can use it for many different types of species. You can also use a Kevlar bag if you want more abrasion, or you can soak it in water to give it a wet rub if you have a species that's especially dusty. When you're finished rubbing, you can put it in a sieve. It's good to have different sizes of sieves with different sizes of holes or different shapes for different types of species. This is so that you can remove different sized debris, or if you want to drop the seeds to the bottom of the sieve, you can do that, or keep the seeds at the top of the sieve. We want to remove as much debris so that we can have a very pure seed. And this brings us to our next machine. This is one of our aspirators. We use it to winnow the seeds. This is to remove debris and increase purity of our seed collections. We'll put the recently cleaned seeds in this cup, which has a mesh bottom so air can go through. You only want to fill it a little bit. We can put it in and then use our adjustable motor to use various different speeds to force air through at various different velocities. It's a very versatile machine and you can use it in several different ways. If the seeds are heavy, you can blow the debris to the top and keep the seeds at the bottom. If the seeds are light, you can blow the seeds to the top and keep the debris at the bottom. Now, when blowing all these debris and increasing the purity of your seeds, you can run into a lot of dust. And this can be a bit of an issue, and that's why we have rooms like this, which have ventilation. And it's very important to wear PPE so that you don't inhale all the dust particles. It's very important to keep your lab clean and orderly. Now we're going to head to our secondary processing lab. We use this lab often in the seasons of summer and fall because that's when a lot of berries are coming in, and it's important to have access to a large sink and running water so that you can wash away the juices and the flesh. We usually use a common food processor because the principle of cleaning berries is through maceration. Though with using a food processor, you have to make sure that you use a plastic blade instead of a metal one because a metal blade can damage the seeds. With a food processor, you can only use it for smaller amounts of seeds. You usually only run about 2 liters of liquid. So this is fine when you're using smaller species such as snowberry, winterberry, or cranberry, but you can also use a macerator for non-berry species such as staghorn sumac to remove all the fluffy material covering the seeds. Once macerated, you put the contents in a sieve and rinse with water to flush out all the juice, debris, and fleshy materials. However, when you get to larger seed lots of perhaps dogwood that come in large buckets with lots of liters, you might want to use a larger macerator such as a Dibvig. When the relative humidity is low in this room, we can also use it for its second purpose, which is our secondary aspirator. It works with the same general principles. We have a cup where we can put the seeds in, which has a mesh bottom, and it blows the seeds to the top, and then the seeds will fall down into these different cups. When you're blowing the debris to the top and removing, say, empty seeds or parasitized seeds, it's important to do spot checks. This is where we use a microscope to make sure that the seeds are dead and empty. But as a general rule of thumb, that seed that's blown to the top, that's parasitized or dead, you want to have about 5% healthy seeds blowing as well, because that ensures that you're removing all the dead seeds and you just have a little bit of extra live seeds that are being blown to the top. And if you're having issues separating the seeds using an aspirator, you can use a vibratory table, which works on the principles of separating items according to their specific gravity. This is good for working on finer seeds where you have smaller dusty debris and very tiny seeds. It doesn't work as well with larger seeds where you might want to use an aspirator. Even after vibrating or using an aspirator, you still can't get rid of all the low vigor seeds. And this is when we bring it to the next step, which is alcohol separation. Alcohol separation is a simple process that uses buoyancy of seeds to separate dead and empty seeds from live ones. To complete this process, you need a funnel attached to a malleable tube with a clamp. We use 95% ethanol because it has less surface tension than water, which allows the viable seeds to sink to the bottom while the non-viable seeds float. It's important to rinse off the seeds after the separation because ethanol can dry out the seeds too quickly and damage them. Once we're finished our processing and we've reached the highest purity level of the seeds we can, the next step will be to conduct a germination test. So let's go to the germinators. This is one of our 9 Conviron germinators that we use to conduct our germination testing. They regulate the temperature, heat, and light conditions that are established by the International Seed Testing Agency or according to different modifications that we've made to ensure maximum germination. Right now, we're germinating red oak and alnus. We always label each germination tray with the exact seed lot number and dates that it goes in and out. And this is very important because we check it weekly to see what the germination results are. Inside, we have water in the bottom of the tray and our cellulose medium with the embryos or seeds inside. When we conduct our germination counts, we do it according to having healthy cotyledons and a healthy radicle. Once we've conducted our germination tests and we've achieved the viability that we want, we're going to put it into long-term storage, into our freezers. So let's go check those out. Right now, we're in one of the 3 freezers we have here at the lab. This freezer is specifically for coniferous species, the second freezer is for deciduous species, and the third freezer is for a conservation collection. I brought this bin of seed from our +4 fridge into our -20 freezer to ensure that condensation doesn't accumulate on the seed. But it's more important to do this when bringing our seed from -20 to room temperature, when filling seed orders or sending seed abroad. We have a 3-step process, bringing it from -20 to +4 and then +4 to room temperature. This ensures that no condensation rushes into the container and messes with the moisture content of the seed. We keep it at -20 because after processing the seed to ensure purity, ensuring that the seed is at the proper moisture content, -20 offers us the best and optimal situation for long-term seed viability. And this completes our tour of the equipment that we have here at our lab.